Welcome everyone to another video on my channel, Vision Basic. If you don't know what Vision Basic is, please check out my previous two videos. They help explain what Vision Basic is in further detail than what you'll get in this one video. Today I'm presenting a kind of tutorial to help you get the most out of Vision Basic. And in this episode, we are going to be discussing sprites. Why sprites? Because they're fun! And many games and programs use them, so I figured that a tutorial on sprites would make for a great first tutorial. Before we continue, whether you find the content of this video informative or not, please make sure to stick around till the end or skip to the end of the video for any extra announcements. Okay, so back to the topic. This isn't a sprites for beginners kind of video, so I'm not going to go into tedious detail here. This video's focus is going to be on sprite shapes that have been created with the Spr-editor sprite editing software that comes free with Vision Basic. So let's see what I've got cooked up in the Spr-editor sprite editor. Here I have created a nice little spaceship in the editor, and we have 4 different shapes for 4 different directional headings. When you save shapes that have been created with the Spr-editor, the sprite attributes like the X expansion, the Y expansion, the sprite colors, and multicolor status are all saved along with the sprite file. These attributes have to be set over here where you can move this on-screen sprites about. So, okay, so we got this little ship here, and here we can change its colors if I can remember how to do it. Let's see. Okay, so we can change the color here with plus and minus. And I need to bring it back. Oh, where are you? Okay, I'm way too far. Okay. Yeah, I think that's it. Okay, so anyways, yeah, I could change whatever color I want it to be. You know, if you want to make it red or whatever. You know, you could change it and it'll save it along with it. And also, we can do X and Y expansion and have that saved along as well. And we can also change the 2 common colors that all the shapes have, which in this case are light blue, and this little flame area here, this is the thrust. But anyhow, all that gets saved with it, along with multicolor mode. We could turn off multicolor mode. And anyways, that's the versatility of the Spr-editor. I'm going to show you how Vision Basic makes use of this information to help set up your sprites more easily. In order to show you how Vision Basic makes working with sprites better and easier, we need to first look at how you might set things up in a regular C64 Basic program. So we're going to go on to our next window here. In the editor, I have whipped up a small program that is kind of like a seed for a simple game. We are going to be making our little rocket ship fly over a stationary starry background and control it with the joystick. Let's see what this program looks like first. And I accidentally moved the screen. Okay. Whoop. Okay. So we're going to type list. The first line loads up the sprite data. I already set the correct loading address in the Spr-editor. Line 10 moves the top of basic memory down so that our variables and such don't garble up our shapes. Here we create just enough room in the first video bank for our 4 shapes. Using the regular C64 text screen at location 1024 requires us to keep our shapes below location 16384. The rest of the lines perform the necessary pokes to set up our sprite for use. Notice all the pokes. And next we are going to list. Okay, this is the setup screen for game section. These lines, I'm going to reiterate, these lines set up the screen and initialize some variables for our rocket ship. The data in line 130 are a series of color values for the ship's thrust and are read into the array variable f. The data in line 135 are colors for the stars in our background that are read into the array variable C. Lines 150 to 170 randomly fill the sky with stars, which are really just colored periods. It's often a good idea to plot the color first before poking the character to the screen, and here we are doing that. So right here we are poking the color, and here we are poking the little period. And in line 180, we have our X and Y coordinates and some directional additives to keep our sprite moving, dx and dy. In line 190, variable sh is for the shape, and variable f is used to cycle the colors for the ship's thrust. I chose F for flame. Because our shapes are being loaded into the top of the first memory bank, we'll be using shape numbers 252 to 255. And right here you can see 252. And here we have our main game loop. And again, this isn't a finished game by any means. Also, I haven't yet tried to optimize the code with little tricks and such. So, in lines 200 and 210, we are poking our sprite X and Y coordinates into the appropriate locations. Since we're only using one sprite, we can cheat a little and set the extra high bit of the sprite X position using a pretty simple expression right here. In lines 220 to 280, we are checking the joystick in port 2 and using the return values to set our directional variables dx and dy, which are added to our x and y variables in line 230. While the directions are being defined, we also define which shape to use by setting variable sh appropriately and then poke sh into location 2040 in line 290. So right here we are defining all of our shapes, 252 all the way down to 255. In lines 300 to 340, we check to see if our sprite shape has gone off screen, and if so, we move the ship to the opposite side of the screen. Sometimes you have to toy with the values here to get the right ones, especially if your sprite is not a full 24 times 21 screen pixels. And line 340 handles the ship's thrust color cycling, and line 350 loops things back to line 200. And before I go further, let's turn the cursor to white. I think we've had at least one complaint about that. I guess some people can't read it very well with the light blue on the dark background, so we're going to change it here now. Alright, it's all simple enough, so let's run our little program. Space, the final frontier. Alright, are you guys ready to see how fast this baby can move? Here we go! Woohoo! Look at her go! Hold on to your seat, Grandma. At this rate, we'll reach Alpha Centauri by lunchtime. Basic is awesome, isn't it? Well, at least the ship can turn on a dime. Woohoo! Here we go. Yay. I'm having too much fun. Alright, for those who are not impressed, relax. Remember, this is a video about Vision Basic, and we're just using regular Basic as a comparison tool. Now, we could try to speed things up by moving the ship 2 or more pixels at a time, but the results will look jerky. So let's see if the code can be optimized. Fortunately, I've already done this, so let's look at an optimized version of the program. Okay, we are in a different window. I have the awesome ability to switch between windows here, so we have already loaded our other version. And let's list. Okay, here I moved line 10 to become line 1. Next, I set up some variables in lines 10 and 11 to replace some long values in the program. When you do this and put them at the front of your programs, it can help speed things up considerably. Okay, moving on. Just a few changes here. I moved the f variable to line 180 from line 190, and in line 190 we are poking our x and y coordinates ahead of time. Also, I eliminated the sh variable, and you'll see why shortly. Okay, so here we have some dramatic optimizations. In line 200, you can see that we only poke our y-coordinate if dy is non-zero, and this indicates that our ship is moving up or down. We also skip line 210 if dy is non-zero, and this saves computer cycles. Line 210 is thus only run when dx is non-zero, indicating that the ship is moving left or right. In line 230, we perform a major optimization. When the joystick isn't being pressed in any direction, we just skip all the lines that have to do with setting the directional additive variables dx and dy. So basically we skip all this. When the joystick is being pressed in a particular direction, we optimize lines 250 to 280 to skip past the lines that follow when a particular if statement rings true. For example, take line 250 here. If j and 4 results in 0, then BASIC quickly skips to the next line. When j and 4 results in a non-zero value, then the code following it gets executed, and then we skip the rest of the joystick interpreting and branch off to line 300. The poke S252 sets our sprite shape for when the user presses the joystick left. Right here. So this one's left, right, up, and down. In line 300, we increment x and y with our directional additives. Simple enough, no changes there. The only changes remaining are the go-tos added to lines 310 to 330. Again, if we skip unnecessary lines, there are speed gains. So this is a very good tip for speeding up your programs. There's just no reason to run lines that don't need to be executed. And finally, in line 350, we have a variable t in place of the value 53285, which is our color cycling of the thrust. I'm sure there are other ways to optimize, but you're only going to get so far with regular C64 BASIC. Let's see if our ship now moves faster. Okay. Now we can compare against our previous example here. Okay, hold on. Okay, so we definitely have some improvement, but how good would a game be if we added another ship to battle against, and if we added lasers and such? We'd probably have to move the ship by larger increments, and the results would probably look jerky. So one trick up our sleeve would be to use the Blitz Compiler. So let's take a look at a compiled version of this specific program. And voila, there you go. Ready to roll. Modern technology. Okay, I already have my shapes loaded. It's important to note that our line at the beginning won't properly load in the sprites after being compiled by Blitz. So you have to load them in ahead of time. I had to tweak the code a little bit. Anyhow, let's go ahead and run it. And there you go. Okay, so this actually looks pretty nice. We do see a little sputtery action in the movement. It's very minor, but it still looks pretty smooth. So Blitz does actually do a pretty good job. But we still haven't added anything else to help turn this into a game. So things will slow down each time we add something. Woo! Okay, I'm having too much fun. Okay, so let's move on over to Vision Basic, the real reason for this video. Now I'm going to type this in from scratch, even though I've already made this conversion once. But I'm doing this so that you can follow the thought process. I think doing this will help you when developing your own games and programs. Okay, first order of business, you should always start your Vision Basic programs with the CLR command. And so, there you go. Otherwise, the variables may contain garbage values, and defining strings could lead to errant pokes that could ultimately crash things. And I'm sure you all know the feeling of when your computer crashes, right? With regular variables, not using CLR shouldn't be a problem if you always set the values for variables before using them. Still, starting every program with a CLR or a clear is a recommended practice. Okay, so let's set up our rem statements. So, does your BASIC do that? Okay, since we need random numbers, it's best to start things off with the random command. Vision Basic's R&D function partly gets its randomness from voice 3 of the SID chip. You should be able to get some OK numbers if you don't use the random command, and you might find a need to go this route if you need voice 3 for something other than the noise waveform. Okay, we only need one decimal variable, so let's do this. Before continuing further, let's look at a memory map and see where we want to put things. By the way, this map appears in the Vision Basic manual for easy reference. If you want to use sprites in Vision Basic, you're probably going to want to move the text screen. If you avoid using any graphics commands, you can place your sprite shapes in bank 0 of C64 memory, but that means you won't be able to use any sprite commands. So we're going to move our text screen far away from all the action. We could place the text screen in the third and final memory bank, with each bank being 16K in size, but that would require us to copy the character set. So to keep things simple, I'm going to go with bank number 2, which is actually the third bank of memory out of 4 available banks in the C64. And I know that all sounds confusing, but that's just the way it is. Some people don't know that with the exception of the color RAM at 55296, the C64 needs to maintain a focus on only one 16K section of RAM at a time when it comes to sprites, characters, the text screen, or the bitmap. They all need to occupy that same 16K space. You can bend this rule with interrupts, of course, but that's a topic for another video. So let's look at the map I've chosen. For simplicity, I could put the text screen at location 32768, but I really want to push the screen as far as I can away from my program and variables and such in case the program were to become huge. I'm pretty sure that I can put the text screen under the basic ROM right here in this area, as I'm not aware of any conflicts with doing so, but just in case there's a tiny chance for some problems, I'm going to go with screen 35 right here. As the program grows, I can always move the screen higher in memory if needed. I want to point out that you can't put sprites, a text screen, or a bitmap screen in this zone right here, anywhere in this region. This is because the C64 video chip sees the character ROM image here and ignores the RAM completely. But this means that we can borrow the character set, numbered 18 here, and we won't have to do any copying of the character set. And by the way, character set 19 is the lowercase set, in case you would like to use that one instead. And we're going to put our sprite shapes here at location 40960, starting here. We can put 128 shapes here if we want in this whole area. A common mistake made by some is not understanding that sprite shape 0 starts up here, right up here on this line here, and sprite shape 255 is located about here. And the sprite shape pointers get moved along with the text screen, so you can't be poking locations 2040 to 2047 and expect to see your sprite shapes change after having moved the text screen around. Again, this is a beginner's mistake. You have to poke the registers that set the shapes follow the screen around and appear on the last 8 bytes, I think. Yeah. Okay, let's get back to our program. Okay, now that we know where our sprites are going to go, let's load them into memory. And we do that with the load command. Oops. Okay, and we now know where our screen is going to be, so let's type vidloc screen 35, and the next parameter is where we want to print to as well, so it needs to be the same, and then our character set. It's very important when you move the text screen around to clear it with the clear character or the CLS command pretty soon thereafter, or you could crash the computer. I think this has to do with the screen line length table, which gets affected by the move. It's also a good idea to restore the screen back to its normal location when exiting your programs, and to clear the screen there as well. Next, we are going to clear our sprite registers. Now, just like in Simon's Basic, I chose the mob prefix because Spr clear just doesn't read very well in my opinion, and Sprite clear is just too long in my opinion. I mean, I had to decide between using a prefix of mob and SBR, and I just chose mob because you could pronounce it easier. Mob clear instead of Spr clear. Now here is the neat trick when using the Spr-editor. We can use one command to easily set our sprite attributes for our spaceship. And there you go. This command takes the attributes from shape number 128, already loaded up into memory, and applies them to sprite 0. So all three colors get applied, and any X and Y expansion and multicolor mode as well. And the initial shape, number 128 itself, is applied to the sprite. And now we need to turn on our sprite 0. And 1 for on. If you look back at our original program, you will see that we have replaced a whole bunch of pokes. The mobset command alone replaces at least 7 pokes all by itself. Now let's set up our next section. And let's set up our screen colors and clear the screen. And I'm just going to copy in a few relatively unchanged lines from the original program. Alrighty. And here is where we plot our stars to the screen that we moved. I'm going to type this in, so bear with me. Okay, one of the things you might notice now is this is our new screen location, 35840, and this is our new additive value for our color position. If you take this value here and you add it to this value here, you will get 55296, which should be familiar to you. Alrighty. In line 150, keep in mind that expressions are strictly calculated from left to right. So, calculated like this. Finally, notice that our default sprite shape is now 128 instead of 252. Now I need to describe the next section. Let's position our sprite with our x and y coordinates, and we do that with the mobxy command. And then it might seem a little confusing, but now we're going to put in our x and y coordinates. Now notice that this has replaced 3 pokes and it functions a lot faster. Okay, this is for joystick number 2, that's why the parameter is 2. Variable OJ is a copy of J for comparison. It's going to help save us some cycles here in a minute. And here it is, if OJ equals J. Okay. Both lines allow us to skip the lines that follow if the joystick is not being pressed, or if the returned value is the same from the time before. That's why I added the OJ variable. I chose a different route for interpreting joystick movements in Vision Basic, so let me type out the lines. 240. And I'm very OCD, so we're trying to line it up. There you go. I'm going to enter these lines again, just make sure they're all in there. Okay. The spaces after the J variable are important, these spaces here, because JAND would be seen as a variable, since variables in Vision Basic are allowed to contain keywords. So this here would be seen as a variable JAND, and thus the reason you need to put the space. dx equals J8. Now the reason why I wrote these lines here should be apparent when I get to the dx here. Kind of simplifies it. Equals J2 minus J1. Okay. One thing to point out about this line is that since integer variables cannot be negative, you might be wondering how the values produced here could work. Well, if J4 happens to be 1, right here, then dx will not be -1, but rather 65535. But when you add 65535 to another integer, it's the equivalent of subtracting 1. So in essence, it still actually works, believe it or not. As an example, watch this. So A equals -1, print A, and B equals 2 plus A, B. Okay. And here you see we told it that A equals -1, but we didn't define it as a decimal variable, so when we print it, we end up with 65535. But we take the 65535 in the variable A and we add it to the 2, which in turn actually acts as the same as subtracting 1. And there's your proof. And some more lines. These lines set the sprite shape based on direction. This is a case where parentheses are allowed in an expression, and these are Boolean expressions here. And this is our familiar x equals x plus dx, y equals y plus dy. Now I'm going to quickly paste in some relatively unchanged lines. And just to make it easier to get out of our program, we will jump back to 200 unless the player presses the joystick button. And we'll do that with this line. P equals button, joystick port 2. If P equals 0, then 200. Means if the button is not pressed, we're going to go back to 200. And to prevent a potential crash upon exit, we will restore the screen back to its default location, as previously mentioned, and clear the screen. Now, it's very important when writing programs in Vision Basic to try to give yourself an easy way out of your programs. It is possible when pressing run, stop, restore to actually exit out of Vision Basic. So it's just easier, a better habit to use something like this, a get statement or something like this, where you can just easily get out of your programs. It's just more elegant and can help you avoid some headaches later on. And now let's cross our fingers and hope that I typed in everything correctly. Okay, let's find out what I did. Arrow. No wonder why that problem had no wonder why that line looked a little weird. Okay. Now let's cross our fingers again. Apparently it didn't work last time, right? Or maybe I just didn't do it. Okay. Alright, here we go. Alright, now compared to Blitz, this runs almost twice as fast, I believe. Not bad, but the neat thing about Vision Basic is that we have a few tricks up our sleeves. So let's see if we can crank up the speed a little. But first I want to play. Okay. And we'll do a little comparison with, see, that's Blitz. And that's ours. Go back to Blitz again. And back to Vision Basic. Now, we can make the stars appear faster, but that's not really necessary. Let's just see what we can do to the main game loop. And here's a simple change. Let. You can use let for simple variable definitions like this, and it actually outputs in pure machine language. And that's a bonus, that's faster. Okay, in lines 220 and 230, we can use the compare command. So we are going to compare j against 0, and then we are going to branch if they are equal. And that's exactly how to read this line. And we are now on the next line, we are going to compare oj against j, and we are going to branch if they are equal, which means we're going to jump to 300. Okay. And this also gets converted to pure machine language. It essentially performs a double compare between two integer variables or values, whatever, and you follow it up with a machine language branch instruction. In this case, the BEQ will perform a goto if both values are equal. Now, the next several lines could be improved to run faster, but this actually won't be necessary, at least at this point, because they don't get executed very often. So let's skip down to line 300. And in 300, we'll just add the add command. Oops. Now, add is another tool that converts things directly to machine language, and it's less confusing than using the compare command. You just simply insert it into the situation. And it's for very simple stuff. You wouldn't want it, you can't use it for like add this plus this plus this plus this. It doesn't work that way. Okay, oops, I'm going all over the place. Let's press enter. Okay, so let's check the results so far. Okay, not bad, not bad. Looking better. But we could do better. So let's use our wonderful compare command again for some more lines. We're going to shorten it to comp so that the lines won't take up two logical lines. So we're going to go up here to 310 and go 1, 2, 3. Okay, comp. We're going to compare x against 5. Compare x against that. Compare y against 31. We're going to compare y against that. And we need to do a little bit more. Okay, we're going to also employ the let command. And finally, I'm going to go with a BCS here. Anyways, whoops. Colon, no. BCS 320. And the next line gets a, oops. No, I'm not looking at what I'm doing. Next line gets a BCC 330. Okay. And another BCS. And another BCC. Make sure we enter it all. Okay, to explain BCS and BCC. BCS will branch if the first value is greater than the second one, but it also branches if the values are equal. So in lines 310 and 330, a branch will occur to the next line if x is greater than or equal to 5, or if y is greater than or equal to 31. And BCC, on the other hand, will only branch if the first value is less than the second one. So in 320 and 340, a branch will occur to the next line if x is less than 343 or y is less than 250. But here we also need to take care of when they are equal. So we'll just change the values a little in order to fix this. So go up here and change this one to 344. And we'll go down here and change this to 250. And that will handle our equal situation. Now these branches act like a then statement when the statement is false, and thus control goes down to the next line. So in this case, if we got BCC, which means greater than, if x is greater than 5, it's going to go to the next line. So we're actually performing a reverse comparison on the values when compared to the original lines. It's a little tricky. But anyhow, the idea is instead of treating it exactly like a then, we are going to branch to the next line for false, and then naturally, when the statement is true, our intended statement, this part will be performed right here. Anyhow, when it comes to differentiating between BCC and BCS, just remember that the C in BCC is less than the S in BCS. So BCC is for less than comparisons, and therefore BCS is for greater than or equal to comparisons. The manual for Vision Basic has a table explaining this for your reference. We also employed let statements. So everything in these 4 lines gets converted into pure machine language. So they're going to execute very quickly. Let's also take care of this while we're at it. We're going to go down to, we're going to change 360. And we're going to keep, we're going to keep the button. But we're going to do a compare. So compare P P to 0. Q 200. Okay, it's a little simpler than what we did to lines 310 to 340, a simple branch if variable P equals 0. And let's run it now. Oops, 310. Lots of different things going on here. Okay, incorrect format. Where is the format problem? Oh, keep forgetting colons. Apparently that is my issue today. Okay. The incorrect format, therefore, was the lack of colons. Alright, well, let's see how fast this goes. Now we're really starting to leave Blitz in the dust. Here we go. Okay, so yeah, we can compare it to our Blitz version, which is kind of chugging along a little slow here. But anyways, okay, back to Vision Basic. Okay, so hopefully you're now seeing why, where Vision Basic strengths are compared to Blitz. Now, let's say you know a little bit of machine language, okay? So we are going to replace line 350 with pure machine language. In this line, we are poking the color register directly because the thrust is one of the shared colors, where we would have to use a command that sets all three sprite colors just to set the one color. So I just chose to poke the register directly for the sake of speed. But again, let's use machine language instead, shall we? So 350 LDA F ASLA ASLA TAY, LDA F, Y, STA 53285, and 355 F, LDA F, and number 7, STA F. I'm not going to explain exactly what this does. The manual covers how to do these things. Pretty sure I even covered the this here. We're loading the accumulator we're loading a value from the array, the F array, into the accumulator using Y as an index. It should be simple enough. But these two lines essentially perform the same exact thing as the original two statements of line 350. Vision Basic allows you to access the variable contents directly with machine language. Like I said, over here we're accessing the lower byte of F here and the lower byte of one of the elements of the array F here. We're increasing the low byte of F. We're also adding ANDing with 7. So yeah, in Vision Basic you can access the contents of your variables using machine language. Anyhow, if this is over your head, you don't have to use machine language. I recommend learning it though. But let's watch what happens when we run the program again. So what are your thoughts at this point? We could go back to Blitz. We could. Or we can go back to regular basic. Or even unoptimized regular basic. Or we could have a chance at making a pretty decent game back in Vision Basic. So the choice is up to you. I just like moving this ship around. Yeah, oops, sorry. Now, when you have a sprite moving around that fast, you might need to slow things down a little. That's where the pause command comes in handy. And in line 200, we're going to insert a pause. Now, what this command does is that it waits for a very particular raster line, for the computer to reach a certain raster line. So as the screen is being drawn, it will, from say top down, it'll wait until you get just past here, and then it's going to wait. It's going to pause until it reaches right about here, and then it'll release everything back to the program. So let's run it and see what happens. Now, you might be wondering why we would want to slow the ship down. Well, the reason to add the pause command is to help smooth out the motion of all the sprites on the screen. We still have plenty of cycles left for other sprites and such. The idea is to make everything run fast enough to perform a single game loop within a full screen refresh. With NTSC, the screen is refreshed 60 times a second, and with PAL, the screen is refreshed 50 times a second. A downside with using this technique is that PAL games will run a little slower, but the benefit for PAL is that you get more cycles per screen refresh. So with our game off to a good start, we can check to see how much of each screen refresh we are using by inserting a couple machine language instructions around the pause command. Okay. Increase 53280 and decrease 53280. Now, what these instructions do is increase the border color before the pause and decrease the color after the pause. And you'll see what this does when we run the program again. Okay, see the black area at the bottom. That is the portion of the screen refresh dedicated to moving our ship. The entire white area is pure wait time. Look at it as kind of like a pie chart. So we're using just a small fraction here of a single screen refresh to move our ship about the screen. So basically in this area here, we're doing everything necessary to move the ship about the screen. And then this portion here, all this white up here, this is just wait time. So we have, theoretically we have plenty of space to, in this area to add another ship, add some lasers and stuff like that. But I do want to point out that when I change directions, hold on, you should be able to notice some sort of black border flicker at the top part of the screen. The lower that the black area goes, the more time is being consumed by the program. Since it goes down a pretty good ways, this indicates that we should probably go back and optimize the part of the program that checks the joystick. This video is getting lengthy, so I'm not going to bother with that now, but further optimization could be accomplished by using the half command in place of the division being used quite extensively in that section of the code, and a handful of let and compare commands could be added there as well. Anyhow, what I'm trying to show you in this exercise is that, the entire exercise, is that you can write your programs using the easier basic commands in Vision Basic, and then when you get everything the way you want it and everything is doing what you need it to be doing, your ship is moving about the screen and shooting lasers at stuff, and you have your sounds in place and such, then you can go back and start to replace some of the slower commands with the faster alternatives as needed. And if you know machine language, you can throw in a little machine language here and there as well. This is exactly how I programmed my Herald game that you might have seen. It's kind of like that Pac-Man game that I created using a cat and mice. this is the versatility that Vision Basic, this is the versatility that Vision Basic brings to the table. Okay, now for a couple bonuses. We're gonna new. Now a couple folks sent me some code and asked me what was wrong with it. That's typical when you're just starting out with Vision Basic. So let's start with one example. And I'm gonna go over to Basic real quick, and we already got it set up. Most of you should be familiar with this, and we're gonna run it. And you see it kind of makes like that little maze pattern, and you know, kind of watch how fast it does it for reference here. Now in let me copy it and put it in Vision Basic. There you go. Now one problem with trying to do this in Vision Basic is that you cannot, you see the CHR, the character function here, it prints characters obviously. You can't embed expressions, you can't use them as parameters, so we're going to have to do a workaround for that. So we're going to start over here and we're going to do random, so we can have random numbers, and we're going to do it this way. We're going to set a toss away variable, as I like to call it. You can use, I mean, like I can use a like all over my program and just do these little calculations here and there. We're going to do RND2 and 1 plus 205, and then we're going to output the character and go do 20. Now here we could use a decimal variable, but instead we're going to keep it integer because integer variables are simply faster for almost everything. Here we are using RND2 to generate a whole number, and we are extracting a single bit from the results and adding it to value 205. So here's where we extract our bit, and then we're adding it to 205. So basically what's going to happen here is it's going to alternate randomly between 205 and 206. And go ahead and run it. And there you go. And compared to Basic, as you can see, there is a substantial difference. Fast, slow, fast, slow. Okay, but let's see. We could use machine language for fun in this example. So now it's still going to be a little machine language. If we use pure machine language, it would just be like blazingly fast. But we're still going to output using the char out or character out function here. So it's not going to be super duper fast, but still, I think you'll be impressed. Oops, I forgot when I did something wrong. This is supposed to be an ad. You guys were like left in suspense, like what's going on? Okay, now let's run it. Woohoo! Now it's a lot faster. So again, Vision Basic, fast. Regular Basic, slow. Are you seeing a pattern yet? Fast, slow, fast, slow, fast, slow. Okay, I think you get it. Alright, anyways, back to Vision Basic here. Break out of it. Sorry. Oops, sorry. Okay. And we're going to go on to our next example. This also was submitted for me to inspect and try to figure out what was wrong. Okay. Alt. Insert. Okay. Alright. First of all, good idea to start things off with CLR. Okay. Now, up here at the top we have some machine language. I think the attempt here is to take the border colors and the screen colors and make them both black. And it appears that that the attempt is to make the character colors white. Now, if the carry flag happens to have a, if it's set before this happens, it's going to turn the color red. So, in order to prevent red from being chosen instead of white, we're going to put CLC here. And that would be the first fix. Now, that is not the actual problem in the program. There are actually a few problems, but one thing, there's no point. I mean, it's cool to experiment with machine language, but for the sake of being able to read the lines and stuff, I'm going to just use the colors command, and this pretty much does the same thing. And speed is not really the utmost important for really any part of the program that I can tell. Okay. Now, where the real problem lies is, now this is an attempt to create a centering function, or a user-defined command as I call it. This is our function center, and it attempts to center the text in the S string variable. Here, the problem is only in the formatting here. When you create user-defined functions in Vision Basic, use a period. Now there may be other languages that permit parentheses as such, but no, in Vision Basic you always use a period, unless you're just you have a routine called draw square, and all it does is draw the same stupid little square, and you just call it, and you don't need to put the period at the end. But anytime you have parameters, you're gonna have to separate it with a period. That kind of tells Vision Basic that you're trying to do a user-defined command, and that you're going to be following it with some parameters. Anyhow, so that is problem number one. We're also going to insert a key press here so that we can witness the screen color change. Otherwise, it just all happens too fast and you don't really get to see the screen color change. So we're going to put that there. And a couple more problems here. When you're passing a variable, it's not passes, it's just pass. And also the local needs to be in front. The local command needs to be in front. This makes everything localized. Just make sure everything is good except 1020. Let me get my notes. Okay. We're going to change 1020 to this. T equals len s dollar. We already have that there. Divided by 2. And then t equals 20 minus t. And then 1020 print. Right. Don't even need the print. Tab t s dollar. And there you go. And that basically should, if I typed everything right, should center our text, which up here is greetings. So let's give it a shot and really hope I didn't screw this one up again. And there you go. The text greetings has been centered. And we do our key press. Now, oops. We could simplify the equation a little further, just keeping in mind order of operation here, and type 1010. T equals 41 minus len length divided by 2. And this basically performs the same thing. So when you run it, there you go. And that kind of simplifies it. Doesn't look a whole lot. It's not really more complicated than what we had before. So even in Vision Basic, not everything has to be complicated as far as like expressions and such here. This is pretty readable. But anyhow, the reason why I'm using 41, I could use 40. Right, can't move up there. Okay. I could use 40. The problem is that I think greetings has an odd number of letters, and the problem with odd, when you're trying to center some text that has an odd number of letters in it, is that you have to decide where that extra letter is going to go. Are you going to have the extra letter kind of off to this side, or you're going to have it off to this side? And that's really the only difference here. Oops. So if we go with 40, you can see that it prints there. And if we change it to 41 and then run it, it prints it there. And again, 41 puts it more in line with the original. So there you go. And all variables start out integer by default, so always keep that in mind as well. So with the division by 2 up here, you're not going to have a trailing 0.5 or anything like that. Okay, before we go, I'd like to point out that for those interested in purchasing Vision Basic, the higher priced packages are up top and the cheaper priced packages are at the bottom of the purchase page. People outside of the United States will get sticker shock when they see the shipping prices, and there's not a whole lot that I can do about that. So I added package 1.0e at the bottom of the page for them because it includes shipping in the price. The manual gets printed and shipped directly from the printer for this package. I plan to add one more package in the upcoming weeks, and occasionally I offer discounts. I often post information on discounts in the video description of the most recent video that that's current, and I remove the information when the sale is over. So if you're looking for a discount, just look there. I'd also like to share a review of Vision Basic from one of my customers. His name is Mr. Burger, and I'm just going to read it to y'all. Here it goes. I just received my Vision Basic launch package today, and from the minute I opened the shipping box, I was completely impressed. If I didn't know this was from one guy working out of his garage, I would swear this package was published by a large software company with hundreds of employees. I absolutely love everything about this sturdy, professional-looking box. Great artwork on the back showing screenshots, the nicely spiral bound user manual, and the good-looking floppy disks and labels. Also, the t-shirt looks great, vibrant colors, and a nice big logo at the front. On the front. I'm really happy I discovered your website and was able to be here at launch. And he's one of my earliest customers. He also goes on, I read the story in the manual about how Vision Basic came to be, and Dennis, I can tell that you poured your heart and soul into this project. Despite all the setbacks and personal hardships you had over those long years, you powered through it all to see your vision become reality. For that, you deserve a big round of applause and congratulations. I've watched your videos and have seen the screenshots, so I know the quality of Vision Basic is extremely high. I can't wait to write some fantastic games with it. Before I finish, let me tell you one of the things I like best about this is, these days most new C64 software development is done with the use of cross-assemblers, CBM, PRG Studio, and emulators that run on PC, Mac, and Linux. There is absolutely nothing wrong with doing this that way. In fact, I have all those tools on my PC. But your software gives me the option to actually develop natively on my old trusty Commodore 128 in C64 mode, of course. For me, there is something just wonderfully comfortable and nostalgic about being able to work with a trusted old friend who I've known for nearly 40 years, my Commodore 128. And from what I can tell, you must feel the same way, having developed this fantastic software package. The last thing I will say to you and others who develop new things for our platform, thank you for your efforts to support our community and keep it alive and well. And I mean, when I read this, I'm reading it off the paper, so it's a little harder to read here, but this really made my day. I mean, this is like, you know, this made 10 years seem worth it. I mean, when you get reviews like this. So, you know, I thank you, Mr. Berger. I hope you're enjoying Vision Basic, and I'm just very thankful for this response. I mean, it kind of leaves me speechless, honestly. So, thank you, Mr. Berger. And finally, I'd like to share a channel that you might enjoy. I invite you all to check out Spiro's channel called Not a Wizard. He's a cool guy with a cool accent, so head on over and show him some love and subscribe to his channel if it interests you. I'll put a link to his YouTube channel in the description. He focuses a lot on programming on the C64 in both BASIC and machine language. And before y'all leave, please help to support my channel by giving this video a like and subscribe to it and share it as well. And thank you for watching. Until next time.